Have you ever wondered if anything can travel faster than light? A question that has intrigued scientists and laymen alike. The speed of light, approximately 300,000 kilometers per second, is considered the ultimate speed limit in our universe, thanks to Albert Einstein's theory of relativity. This theory, which has stood the test of time, posits that nothing can move faster than light in a vacuum. The reason behind this lies in the concept of space-time. As an object accelerates towards the speed of light, its relative mass increases, requiring more energy to continue accelerating. Eventually, it would need infinite energy to reach or exceed the speed of light, which is, of course, impossible. So, the speed of light stands as an unbroken barrier, a cosmic speed limit that appears unchallengeable. So, if we can't exceed the speed of light, could there be another way to traverse vast distances quickly? Scene script. Faster-than-light travel is a concept that has fascinated scientists and science fiction lovers alike. Picture this. You want to get from point A to point B. In our everyday experience, we just move in a straight line, right? But what if we could fold the space between these points, bringing them together? Suddenly, the distance isn't so great. This is the essence of faster-than-light travel. It's not about moving faster than light, but rather bending or warping the fabric of space-time itself. Imagine space-time as a sheet of rubber. When something with mass or energy, like a planet or a star, sits on this sheet, it creates a dip, a warp. Now, if we could create a significant enough warp or shortcut in space-time, we could effectively reduce the distance between 2 points, allowing us to travel faster than light, at least from an outside perspective. Now let's talk about the theoretical entities that might make this possible. Wormholes and the Alcubierre drive. Wormholes, in theory, are like tunnels through space-time. They connect 2 distant points with a shortcut, like a cosmic back alley. If we could create or find and traverse such a wormhole, we could potentially reach distant parts of the universe in a blink of an eye. On the other hand, the Alcubierre drive, proposed by physicist Miguel Alcubierre, involves creating a bubble of space-time around a spacecraft. This bubble would contract space in front of the ship and expand it behind, effectively moving the ship across the universe faster than light, again, from an outside perspective. It's like moving the walkway under your feet instead of walking. These concepts, while still theoretical, provide us with a tantalizing glimpse into the possibilities of faster-than-light travel. They show us that the universe's speed limit might not be as absolute as we once thought. In theory, these concepts might allow us to cheat the speed limit set by light. But how feasible are they? Wormholes, tunnels through space-time sound like the perfect solution to our interstellar travel problems. But what exactly are these mysterious structures and how do they work? Well, to put it simply, a wormhole is a hypothetical structure linking disparate points in space-time. It's like threading a needle with the fabric of the universe, linking 2 points that would otherwise be light years apart. Physicists theorize that wormholes could potentially enable faster-than-light travel, not by breaking the cosmic speed limit, but by providing shortcuts through space. Imagine a universe folded in half, and a wormhole is the needle piercing through the fold, connecting 2 points in a way that bypasses the usual space in between. However, wormholes aren't just convenient cosmic shortcuts. They're incredibly complex and unstable structures. Theoretical physicists have suggested that wormholes might be kept open through the use of exotic matter or cosmic strings, substances, and phenomena that are still largely theoretical and poorly understood. And there's no guarantee that a wormhole, once created, would remain stable or open for any useful length of time. Then there's the energy requirement. Creating a wormhole, according to our current understanding of physics, would require a staggering amount of energy. We're talking about levels of energy so immense that they're currently beyond our ability to generate or even fully comprehend. Furthermore, there's still much we don't understand about wormholes. They exist primarily in the realm of theoretical physics, and while they make for compelling science fiction, we're a long way from having a practical understanding of how they might be used for interstellar travel. In conclusion, wormholes offer a tantalizing glimpse into the possibilities of faster-than-light travel. They could provide a shortcut through the vast distances of space, making interstellar travel a reality. But their creation, maintenance, and use present enormous challenges. Wormholes might be a theoretical solution, but their practical implementation is fraught with challenges. If wormholes are tricky, could we potentially warp space-time ourselves? Enter the Alcubierre drive, a theoretical propulsion system that might just make faster-than-light travel possible. The concept is as audacious as it is ingenious, and it's named after the brilliant physicist Miguel Alcubierre, who first proposed the idea in 1994. Here's a simplified version of how it's supposed to work. The Alcubierre drive doesn't actually propel the spacecraft in the traditional sense. Instead, it manipulates the very fabric of spacetime. It contracts space in front of the spacecraft and expands it behind. This creates a sort of bubble of flat spacetime where the ship resides. So while the ship isn't technically moving, the space around it is, allowing it to traverse vast cosmic distances in effectively less time than light. Now, before you start packing your bags for a trip to Alpha Centauri, there are a couple of gigantic, or should I say astronomical, hurdles to overcome. First and foremost, the energy required to warp spacetime in this way is immense. We're talking about the equivalent of the mass energy of Jupiter. That's right, an entire planet converted into energy, and that's a conservative estimate. Secondly, this isn't something we can just plug into a wall socket. The kind of energy we're talking about is exotic, negative energy. It's a mysterious form of energy that's predicted by the equations of general relativity but has never been observed in nature. Finally, even if we had the energy and the technology to manipulate it, we'd also need a way to control the space-time bubble. At this point, our understanding of the physics involved is still largely theoretical. The Alcubierre drive might be our ticket to the stars, but it's currently beyond our technological grasp. Yet who knows what the future holds? After all, it was once unthinkable that humans could fly, let alone reach the moon. So keep dreaming, stargazers. The universe is full of surprises. So, is faster-than-light travel just a pipe dream? Well, as the saying goes, never say never. The realm of quantum physics is rife with possibilities that seem to come straight out of science fiction. And it's here, in the world of the incredibly small, that some scientists believe the key to faster-than-light travel could be hiding. At this very moment, researchers across the globe are exploring the bizarre and mind-bending world of quantum mechanics, probing the fabric of reality itself for answers. They are delving into phenomena like quantum entanglement, where particles, no matter how far apart, appear to affect each other instantaneously. Could this be a clue to faster-than-light communication or even travel? Quantum tunneling, another peculiar quantum phenomenon, has particles seemingly pass through barriers as if they weren't there. Some speculate that this could be a stepping stone towards understanding how we might slip through the fabric of space-time itself. But let's not get ahead of ourselves. As it stands, faster-than-light travel remains in the realm of theory and speculation. The laws of physics, as we currently understand them, simply do not allow for it. Traveling faster than light would require an infinite amount of energy, and we are yet to discover a way to bypass this cosmic speed limit. However, the future of fast interstellar travel is not a closed book. We live in an era of rapid scientific and technological advancement. What was once impossible becomes probable, and what was once a dream becomes reality. The universe is a place of infinite wonder and complexity, where the laws of physics often seem more like suggestions than hard rules. As our understanding of the universe deepens, so too do the possibilities for exploration and discovery. The universe is vast and full of mysteries, and who knows, maybe one day we'll find a way to explore it faster than light.